Assalamu alaikum dear students. In the series of learning object-oriented programming C++, we are discussing the features of object-oriented programming languages. In the previous video, we have discussed three main features of object-oriented programming languages. Those are their classes, objects and inheritance. Every minute detail regarding these three features have been thoroughly discussed in the previous video with the help of the examples. So, in today's video, we are going to discuss three more features of the object-oriented programming methodology, that is the data abstraction, encapsulation and polymorphism. These three features will be discussed in today's video with the help of the example. So, in today's topic, that is the features of object-oriented programming part 2, we are going to discuss these three features. As I have already told you that there are mainly six characteristics of object-oriented programming languages. They are the object, class, inheritance, data abstraction, encapsulation, and polymorphism. Among these six features or six characters of the object-oriented programming methodology, these four, that is the inheritance, data abstraction, encapsulation, and polymorphism, are also called pillars of object-oriented programming languages. So, in previous video, that is in features of object-oriented programming part 1, we have discussed these three features. Now, in today's video, we are going to discuss these three pillars of the object-oriented programming methodology. So, first we will see what is data abstraction. What is data abstraction? We can also call it as a data hiding. Data abstraction also means data hiding. First of all, let us relate this data abstraction with the real world example. For example, if I am driving a car and I want to stop the car at some point, at some station, what I have to do? I have only to apply the brakes. Whenever I apply the brakes to my car, the car stops. But how these brakes works internally? What is the mechanism behind the brakes? Behind how these brakes works internally? I don't know those things. I am only knowing, as a driver, I am only knowing how to stop a car. I know that I have to apply a brake. Whenever I apply the brake, the car stops. And internally, what is happening internally? What is the mechanism behind the scene, or we can say what is happening behind the scene? I don't know that things. So, the implementation details are going to be hidden from me as a user. I am a user. I only know by applying the brakes, the car can stop. I could stop the car by applying the brakes. But how the car stops, that I doesn't know. Neither I am interested in that, because that is the job of the mechanic. Mechanics knows what is happening behind the scene. So that means some internal details are going to be hidden from me, and only those details, only those things which are beneficial for me, which are useful for me, are going to be shown. That is called data abstraction. What is actually data abstraction? That means hiding the implementation details from the user. Data abstraction means it is a process of hiding the implementation details from the user, and only those details, only those things are going to be shown which are essential for me. That is called the data abstraction. So this data abstraction is one of the most important feature of the object-oriented programming methodology. This is one of the most important of the object-oriented programming methodology. So data abstraction, what is data abstraction? Actually, the data abstraction means to hide the implementation details from the user. How the working internally the working takes place. The user is only whenever, for example, in programming, whenever I am going to write a function, for example, CLR, clear screen. As a user, I only know clear screen, the working of this clear screen to erase the previous output from the screen. It's a function, it's a working, it is the purpose of this clear screen. But the code, the implementation details, for example, I know that this is an inbuilt function in C++ or in a C. So inbuilt function, it is defined in the C++ library or in a programming language library. There, I don't have anything about the code. What is the implementation details of this function? As a user, I only know to write, if I write this clear screen, then it will erase the output. That is going to be one of the important, that is the abstraction. So abstraction, it means simply to hide the implementation details from the user. To hide, we can and show the relevant details only. That means that to show the user only those details in which he is interesting, which are useful to him. And what is happening in the background, that is going to be hidden from the user. And that concept is called the data abstraction, or we can say a data hiding. One more example, we can relate this phenomena, this feature with the real world as well. One more example of the real world is that, for example, whenever we switch on our computer, we only press the on button, power on button, and our computer is going to be on. The power supply is whenever we press this on button, the computer is going to be started. It starts this function. But what is going to be behind? We only know, we are interested only in pressing the power button. And what is the mechanism behind that power button? We are not interested in that. Because we have to only know by pressing the power button, our computer gets on. So what is the mechanism behind that? That is going to be hidden from the user. And that is the data abstraction. We only know the function, what is function, and what is happening out behind that function, that remains hidden from the user. That is called the data abstraction. So data abstraction is nothing. It is the process of hiding the implementation details from the user and only showing those details, only showing the relevant details to the user. Rest of details are going to be hidden, and that is called the data abstraction, or we can say a data hiding, which is one of the most important feature of the object-oriented programming methodology. And after that, there is one more concept, that is the encapsulation. What is encapsulation actually? Encapsulation. If we relate this encapsulation is also one of the most important feature, or we can say the characteristics of the object-oriented programming methodology. If we relate this encapsulation with the real world example, for example, encapsulate, that means wrap. Encapsulation is a wrapping of the data and a function into a single unit, or you can say wrapping of the data and a method into a single unit. That is called the encapsulation. In the real world, for example, if we take the example of the chocolate, if we go to the shop and we bring there a chocolate, that chocolate is encapsulated, that is wrapped in a cover, and inside the cover there is the chocolate. By seeing the color of that cover of that chocolate, we cannot say what is the color of the chocolate inside or what is inside. If we give that chocolate to someone who doesn't have, who do not have seen the chocolate before, and he will not guess it is a chocolate, because that is wrapped into a data, into a cover. That wrapping of the data in C++, in programming language, in the coding, the wrapping of the data and function, data and code, or you can say function, into a single unit, is called encapsulation, and this mechanism is called encapsulation. For example, if for example, this is data and this is function, and it is called object. For example, it is an object. This data object, for example, this is an object. We know that what is this entity. Object is an entity. It is associated with the functions and the properties. Here also, for example, if this is the name, this is some student, for example, student. We know that student have properties, for example, roll number, name, parentage, class, marks. These are and it have also some functionality for he read, walk, eat, write. These are the functions which are associated with this object. And here this function and the data is wrapped under this cover. That is a cover outside this object. Okay, this is called encapsulation. Wrapping of the data and the function in a single unit. Here I have put this data and the function wrapped. That means we cannot access these things from the outside. Okay. So this phenomena is called the encapsulation, which is one of the most important feature of the object-oriented programming methodology. So what is encapsulation? It is a wrapping of the data and a function into a single unit. That is called a encapsulation. And sometimes encapsulation is also called as a data harding. Now the question is, in programming, how we achieve this encapsulation? We know that in the C++ or in object-oriented programming methodology, there are some access specifiers. For example, private, public, and protected. If we put this, if we declare this object, or we can say this data, as a private, and the function, this method of function, as a public, only these functions can access the data, this data. Nobody outside this function can access this data. Okay, that if I want to perform some functions, if I perform operation on this data, only these functions are able to access this data. They are able to perform these functions on this data, because I have declared these data access specifier which I have put here are private. We know that private the data or the functions which we declare private cannot be accessed from anywhere or from the outside of that class. So if only the members of this functions of this class, this object can, or we can say this class can access this data. So we can say that encapsulation provides security to our data, which is one of the most important feature of the object-oriented programming methodology, which I have already told you that in procedural-oriented programming methodology, there is a compromise on the security of the data. In order to avoid those things, in order to avoid that disadvantage, a new methodology comes into existence, that is the object-oriented programming methodology, because of the security. Because here the emphasis or importance is given to the data rather than on the functions. So here this encapsulation we can implement, we can achieve this encapsulation by using the access specifiers in C++. The access specifiers which are available to us are the public, private, and protected. If we declare data as a private, only the functions of that particular class can access that data. We cannot access that data from outside the class. So we can say that encapsulation In other words, we can say that this encapsulation prevents the unauthorized access to the data. Hope you have understood. Now, what is encapsulation? Encapsulation, it is we can also call it a data hiding as well. We can also call it, sometimes it is a data hiding, because by putting this cover outside our data and functions which are going to hide these things, implementation things from the outside world. So it is also called sometimes the data hiding as well. So encapsulation is one of the most important, we can say the fundamental pillar of this object-oriented programming methodology, because it provides security to our data. It increases the security to our data, because data, the precious resource, the important resource in any software, or we can say in any company, is our data. Data is the precious, data is the one of the most we can say valuable resource, sensitive resource. So that must be secured. So this encapsulation helps us in providing the security, increasing the security of this data. Hope, and inshallah in next video we will discuss all these features one by one in separate videos with the help of the examples, with their implementation details as well. Here only I am only giving you the concept, what's the concept behind these things, brief concept, brief explanation of these pillars. And now last one is the polymorphism. So what is polymorphism? As we know, polymer is many and morphism means forms. That means many forms, more than one form. We can say more than one form. And I will also try to relate this polymorphism feature, this polymorphism concept with the real world. For example, if I will take the example of myself. If I am a teacher, for example, I am a teacher. So what I am going to perform? In a class, if I am teaching someone, that there I am acting as a teacher. Okay. And I am also the friend of my friend circle. If I have a friend, I am also the friend of someone. And I am also the subordinate of someone. So I, for example, I am a single person, and when I am a teacher in a class, I behave differently with the students. There I am acting as a faculty member, and whenever I am talking to my friend, there I behave differently with my friends. So I can say that my behavior changes according to my situation. When I am talking with my friends, there I am talking with them with some way, and when I am talking with my students, there I have to talk them other way. So I put myself, I behave differently in different situations, and when I am talking to my boss, there I have to talk some other way. So I can say that only one person is only one I, and I am behaving differently. With my students, I have to behave one way. When I am with a friend, there I can behave in some other way. And when I am talking with my boss, there I have to behave some other way. This is the real world example of the polymorphism. Person is only one, but according to situation, he is performing different roles, or you can say. So in programming, here also, with the help of here example, for example, here I will write. For example, here I will write sum int x int y, sum integer x float y, sum integer x integer y, integer z, sum float x, float y. Take care. In programming, we can achieve this polymorphism by two ways, either by overriding or by overloading, either with the operator overloading or by function overloading. So we can achieve the polymorphism in programming in code by two ways, overloading and overriding. First of all, here we know that sum is the name of the function. Depending upon the arguments, there are the arguments x and y. That means this sum is taking two arguments of both type integer x and y. Here this sum function is performing the addition of the two numbers, but those numbers are of type integer. For example, 5 and 6 we can see, that means 11. This function name is sum, and it takes according to its argument, here two arguments are going to be passed, x and y. That means, for example, if these arguments are 5 and 6, and it will print 11. Here this name is sum, but here it takes two arguments. First argument is integer and second argument is float. Here also it performs the addition of two numbers, but two different types of data. First one is the integer data and second argument is of type float data. The working is same, but according to these arguments, or you can say the parameters, it behaves differently. Here it performs the addition of one float and one integer. Here it performs the addition of two integers, and here in this case it performs the addition of three numbers, and all the three numbers are integer type. And here it performs the addition of two numbers. All the two numbers are floating type numbers. So we can say that according to these arguments, this function behaves differently. It performs addition. Obviously, it performs addition, but here it performs the addition of two numbers. Here it performs the addition of integer and float number. Here it performs the addition of three numbers, and here it is going to perform the addition of two floating point numbers. This is called function overloading. In overloading, what is going to take? The name is same. Polymorphism. Poly means different, many. Morphism means forms. Here this sum behaves in many forms depending upon this argument. This is called a function overloading. And what is function overriding? Function overriding is that here the implementation details changes. That means, for example, if I have a function, I will take the example upon here, this one. Take here. If here I have a function sum x and y. Okay, and in definition of this function, what is going to tell? Here, what I want s is x plus y, for example. Objective is I want the addition of two numbers. For example, if x is equal to 10 and y equal to 5. So here I want that x must have 10 plus 5 equal to 15. But in implementation here, what happens here? Here s equal to x minus y. Here it is going to perform the subtraction of two numbers. So we can say here the implementation is going to be changed. Actually, I want the sum of two numbers, but here in definition, what is happening? The subtraction of two numbers takes place. So it changes the implementation details. This is called overriding. Name is same. I hope now you have understood what is the difference between the function overloading and function overriding. And we can achieve this polymorphism by two ways in functions: function overloading and function overriding. And also we can achieve this polymorphism in the operator overloading as well. Inshallah, in the next video we will discuss these polymorphism also in separate videos with the help of the example and its implementation details as well. I now hope that you have now understood what is the object, what is class, what is inheritance, data abstraction, encapsulation, polymorphism, because I tried to briefly explain these things here. In the next videos we will explain, we will discuss these things very minutely, very broadly in separate videos in the next videos. Till the next videos, take care, bye bye.